So, ang ano ko sana, doon sa Marinduque State College, that's where my wife came from. Okay. Para makapagbakasyon din yung mga bata. Ang dami yung ano sa akin, offer kahit nga doon sa Lukban, yung school dyan sa Lukban.
Sa Quezon.
Mm-hmm.
So, dumaan ka din na UPLB.
Opo, for sure po.
Mm-hmm.
So, ang gagawin natin ngayon, class, what we're going to do is just the common calculation. So, this is in addition doon sa sample problem na that was given in the handout. Okay? So, these are the problems that you're going to expect to solve. So, once you get this, it's routinary. Usually, the only thing that you need to do here is just like preparing a linear regression or a calibration curve. Now, the thing is, you know, during board exam, hindi kayo makagagamit ng Excel. So, I hope you're going to be familiar. Maybe I'll send you a link in our Facebook page on how to use a calculator to get the y equals to mx plus b. That's most of the problem that you're going to have. And the one that is similar when we're starting the course, the standard addition. Okay. So what I have here is the common problem in absorbance, emission, and AAS. And special topic dito, yung tinatawag nating simultaneous determination. So if you have a mixture, okay, how are you going to determine the component, each component of a given mixture? So yun yung ano ko ngayon. I think I have, if I'm not mistaken, 6 problems, okay, that we're going to solve. So these are the common one. Ito ang una, it's just we could say the basic spectroscopy problem. So ano dito, a sample has a percent transmittance of 50%. So what is its absorbance? So you have to look at the relationship between absorbance and transmittance, and that's just equals to what? A equals to negative log of t. So maybe sa quiz ninyo, sa multiple choice quiz ninyo, pwedeng ganito yung problem doon. Okay? Wala tayong quiz, but I'm going to give you like some sort of an assignment. Okay? So every meeting. And then next meeting, we'll finish spectroscopy. So i-wrap up natin. I'm going to introduce to you siguro sa recording yung vibrational spectroscopy, and then we go to mass spectrometry. And then standby kayo sa Thursday because I have my booster shot on Wednesday. Oh, and I think we can meet because I remember my appointment is a Wednesday afternoon. So I think I'm still okay by Wednesday night, which is the Thursday during that time. So I think mag-meet tayo. Okay? Because we don't know what will happen with the booster shot. The second time I have it, I really have to whole day in bed. So this is the formula. So all you need to do is what? You replace that with the 50%. So 50% is equals to this. So what do you get? Ano yung nakukuha nyo?
0.30 po.
0.30
po.
30. Okay? So, siguro, sure points na to when we have this in quiz. Okay? We're going to have simple problem in quiz, siguro like this one and the next one. So these are the straightforward, we could say, calculations. So yun yung parang one-step calculation. So the one that you need, we say, linear regression. Okay, but I think in the board exam, those are the type of questions that you're going to be asked. Okay, so here, this is another what we call common spectroscopic problem. So you have a 5.0 times 10 to the negative 4 molar solution of analyte. It's placed in a sample cell that has a path length of 1 centimeter. So at a wavelength of 490 nanometer, the solution's absorbance is 0.338. So you're asked, what is the analyte's molar absorptivity? So the formula that you have there is just this one, right? Or your molar absorptivity mo, like this. And if you're going to look at here, this one is given, path length is given, okay, and the concentration is given. So all you need to do is to get for that one. So if you're going to do it, you just divide both sides by BC. And then you have here, replace with the given value, 0.338. And then you have 1 centimeter. And then you have the 5.00 times 10 to the negative 4 molar. So the unit that you have here will be per molar per centimeter. So ito yung mga straightforward na magiging question ninyo that deals with calculation. So ano yung nakukuha yung sagot?
676 po.
So this is your answer. And that's the basis. I'm not sure if you have this, what we call clinical test. So what some company do, they develop their own method and then patent it. So the way that they look at it, it's at a particular wavelength. So all you need to do, if you have a blood or urine, okay, they just get the reading on it. So they already know the corresponding molar absorptivity in your compound that they analyze. And all you need to do is determine the corresponding concentration. Because other type of problem here would be you're given the molar absorptivity and you're going to get the concentration. So if that happened, you just play around with the formula. So if the one that is given is the molar absorptivity, okay, and the path length, so it will just be like this one. And you're going to get the concentration. So ganun lang yung pag-manipulate ng formula ng Beers-Lambert law. So it's just mostly like this one. One thing that you need to know. So since it's always one here, so usually ang ginagawa nila is just like this one. And this is your, if you do the calibration curve, that's your
Slope.
slope. Okay. So yan yung typical na makikita mong tanong. I always see it in the ACS. Both, no, not Chem, but analytical chemistry. Because usually I use ACS exam for my student in their final exam. Okay. Now this is the one, the next problem. On our what we call course, you can use Excel, but we all know when you take the board exam, okay, you don't have access to Excel. So you have to use a calculator that is allowed, and you have to use that calculator on getting. Ang kinukuha naman dun is YMX plus B. And I think depending on the model of the calculator, there's a way for you to do it. Okay, the one that I know is you enter the XY value. Okay, so ito yung X, ito yung Y, XY, XY. And then once you're going to get that, you're given what we call the value of the slope and the Y-intercept. And once you get that, okay, So for this sample here, ano tong absorbance na to? Saan yan magpo-fall dito sa equation of the line? Yan ba yung y o yung x? Okay, so that is your y. So once you have that, so all you need to do is rearrange this one. So the way that you do it is y minus b, okay, and then that's m. Oh, you get the x. So you divide that by the slope to give you the corresponding x. So the most crucial thing here is this one. Y equals to mx plus b. Okay. Now, since I cannot show you a calculator how to do the thing, so I can use the Excel. I hope I have opened my Excel. So can you see my Excel?
Hindi pa po,
Hindi
sir.
pa po.
Hindi kita. Teka lang. Ito, kita. Excel ba yung nakikita nyo? Hindi pa
Opo.
rin. Okay.
Okay na po.
Okay. So here, in our course, we usually, in both analytical courses that I'm teaching, some part of the lab, okay, they need to use Excel. So I don't know how you do it in your 32 and 137.1, okay? Because what I ask my student is when they submit report, I want them to have an Excel on the day on how they process the data. Okay. So all you need to do is just input this thing. Pero sabi ko nga sa inyo, wala kayong Excel doon sa board exam nyo. So you have to know how to use the calculator doing this so-called linear regression. So once you put there the X and the Y axis, so usually we just highlight it and then go to insert. I think all of you knows how to do it. Okay. And then once you have that, you just use add trend line to get the equation and maybe the R squared. And you could see it's really a straight line because Y is equals to 1. Now, ang kailangan nyo lang dito ay kunin yung y equals to mx plus b. Which if you look at the Excel, that's just y equals to, nasaan yun? So, 0.187 0.1817. Mali ako. Plus 0.0006. So I have to. So this is the one that we get when we plot. So what we're going to do is to solve for the x given the 0.269. So that is your y. And then you subtract it with 0.0006 over 0.1817, which is your x when you do the calculation. So what is the milligram of Fe per liter?
1.48 po.
1.48.
48.
So medyo madali lang siya, di ba? Ang problema lang dito is you have to be very careful. So carelessness is your main, we could say, enemy here. So pag masyado kang nagmamadali, okay, you might end up getting the wrong answer. But if you just follow it carefully and then observe, do the calculation several times, check it, okay, double check or triple check it, and then I think everything will be okay. So this type of question, we will put this in the problem set. So yung mga multiple choice question, yung the two previous problem that we have. Now, let's go to the challenging one, like this one. Okay. So here, this is, we could say, a double component problem. And usually a double component problem, if you're going to look at it, they have different lambda max. Okay. So what you're going to do is you're going to measure what's the composition of the mixture once you get the absorbance at those two wavelengths that has the lambda max of each of them. So for instance here, you have a mixture of ferric ion and copper 2 plus. So it says that the concentration of ferric ion and copper 2 plus in a mixture are determined following the reaction with hexacyanorutenate, okay, which forms a purple blue complex with Fe3 plus with lambda max at 550 nanometer and a pale green complex with copper with lambda max at 396 nanometer. And the molar absorptivities for the metal complex at the two wavelengths are summarized in the following table. Okay, so there's the lambda max, or we could say the molar absorptivity of 550. For Fe, you have this. For copper, you have this one. So that means the 550 is the lambda max of what element? And the 396 is the lambda max of the what element based on this given molar absorptivity. So this is for your Fe3 plus, and this is for your copper 2 plus. So usually makikita mo sigurong absorbance is just like this and like that. So this is around the 550 and this is around the 396. So that means if you just have Fe in your sample, it would look like this. And if you just have copper in your sample, it would look like this. So how do we solve problems on a problem like this? So it says here, when a sample that contains Fe3 plus and copper 2 plus is analyzed in a cell with a path length of 1 centimeter, the absorbance at 550 nanometer is 0.183, and the absorbance at 396 nanometer is 0.109. So what are the molar concentrations of Fe3 plus and copper 2 plus in the given sample? Okay, so the principle that we have to look at this is still Beer's law. Okay, so when we say Beer's law, we still follow this one. Now, the good thing with the Beer's law is yung tinatawag nating nature na additive. So mag-a-add lang yung absorbance ng different sample. So as I've told you, kapag copper ka lang, meron kang ganon. Kapag Fe ka, meron kang ganon. So pag kinombine mo sila, dalawa yung peak na makikita mo simultaneously. Okay? So the way that you're going to do it is this region here. Okay? The absorbance that you have there is the summation of the copper 2 plus that you have here and the Fe3 plus that you have on that region. So the same thing here, the absorbance that you have there is just the sum of these two. So paano natin aanuhin yun? So gagamitin natin yung Beers-Lambert law. So the way that we're going to look at is we have the absorbance of the mixture, and then we can assign this as what? Lambda 1, lambda 2. So we could say absorbance of mixture lambda 1, and then absorbance of mixture lambda 2. So when you say lambda 1, that's a first wavelength, and then lambda 2 second wavelength. And then we're going to put there this thing. Okay. So the molar absorptivity, let's say we designate one as X times the path length and the concentration of X. And the other one, ano yung designation natin doon sa other one? Pwede nating sabihin na molar absorptivity of Y times the path length and the concentration of Y. So that's at the given wavelength. And we do the same thing with the other one. So the molar absorptivity. So this is at what we call the given wavelength there, okay? So this is 2, and then I put there Y1, and then B times CX, and then molar absorptivity of Y at lambda 2, and then B times CY. So we know the values of this because they're given. If you're going to look at the problem that we have there, they gave these values here. And what else that they gave there? They gave the absorbance. Okay. So if we're going to what we call put them in terms, let's say, absorbance at 550 and absorbance at 396. Okay. So we go to the whiteboard. So the absorbance at 550, we could say that is equals to what? 0.183. And then we can get it from the total that we have, let's say, here, ano yung molar absorptivity? 9970, okay, and 34, right? So that is, we can just discard the B because it's equals to 1, okay? But we're going to put here the concentration of the Fe, and then this one is 34, the concentration of the copper. And then we're going to have the 396, so that's 0.109 equals to, trying to look at the molar absorptivity. So you have there the 84 for Fe, concentration of Fe, plus 85, what's the molar absorptivity there? 856 C copper. So what do we determine? The CFE and C copper. So what do we do? Anyone? Anong gagawin natin? I think yung assignment na ibibigay ko sa inyo is a problem like this. So we have what? Two unknowns. So whenever we have two unknowns, what do we do? Anyone? Any suggestion? There are several ways to solve this one. So whenever we have two unknowns, what do we do? Okay, we express one of the unknown just like the other unknown. So maybe i-express natin, we can use either the CU in terms of the CFE or the CFE in terms of the CU. Okay, so the way I'm going to do it is maybe I'm going to express the relationship of this with respect to the CFE. And I can use the first formula. So anong gagawin ko dito? I'm going to isolate the C concentration of copper on one side. And when that happens, paano yung mangyayari if I have a CCU here? So maybe I can get 0.183 minus, okay, 9970 CFE divided by what? 34? You follow where I get this? Ni-rearrange ko lang tong expression dito. So let's say I move this on that side, and then para maging CCU, I divide it both sides by 34. Na-follow niyo ba, class? Kung paano ko na ito, in-express ko like this one.
Yes po.
Okay? So, anong gagawin ko ngayon? Papalitan ko tong expression dito with this whole expression. So, I may end up with what? 0.109 equals to 84 CFE. And then I have here what? 856. And then I'm going to put the whole thing. 0.183 minus 9970 CFE over 34. So ngayon, isa na lang yung unknown natin. Right? Yung unknown na lang natin is yung concentration ng FE. Na-follow ba, class? Because once we can do it is we could say put on one side yung pareho and then put on the other side the one that is not what we call the same. So if we're going to do this one, so 0.186 times 0.183 divided by 34, I think you will get here like a 4607, right? And then minus 856 times negative, since minus na siya, 856 times 9970 divided by 34. So you will get there around 2.51 times 10 to the 1, 2, 3, 4, 5. So ito yung dito sa side na to. This one. And this is what? CU. Yung ano dito, That's really a CFE. And as you could see, napakaliit no number nila dito. So you will end up with what? For CFE. Since you have a big number here, so the way that you're going to rearrange there is just 4.607. Okay. I can move this one because this is a negative. So maybe I can just move this one here. No, that's CFE plus 84, or no, that's not a plus, that's a minus 84 CFE, and on this side you have 4.607 minus 0.109. And then if you're going to look at this, so parang 2.51 times 10 to the 5 pa rin tong CFE. And this one will be 4.607 minus 0.109. So you have 4.498. So if you're going to look for the CFE, you're going to divide both sides by this. At ano yung makukuha nyo? Let's put a negative. So you get around 1.79.
1.79 times 10 raised to negative 5 po.
Negative
5 po.
5. So that is your concentration of Fe. Okay? So you solved already the CFE. So how are we going to solve now the copper? So you just going to what we call use either of the expression here, okay, to solve for the concentration of the copper. So maybe I can use, hopefully may space ako dito, this one. And then I have 9970, and I'm going to use there the 1.79 times 10 to the 5 plus 34 concentration of the copper. So if I have that, okay, 9970 times the 1.79, so I will get here around 0.179 plus 34 CCU. So I can move this here. 0.183 minus 0.179 equals to 34 CCU. And all I need is to divide both sides by 34. So ano yung concentration ng copper nyo? 0.183 minus 0.179. By 34. So you're going to get there around
1.26 times 10 raised to negative 4 po.
126 times 10 to the negative 4. So ano, kaya? Question? No, there's another way to what we call do this. So I clear ko lahat. Okay. So remember, you have there the absorbance at 550, which is 0.183 equals to 9970 concentration of your Fe plus 34 the concentration of your copper. And then the other one you have there at 395, which is equals to 109.84 CFE plus 856 copper concentration. So another approach that you have here is maybe multiply this whole thing by what? 856 over 34. Why? Why did we choose that number? Anyone? We choose that number because of this. 34 and 856. So it's just like we're trying to cancel out the concentration of copper here, because what we're going to do is we're going to subtract. We're going to do like a simultaneous subtraction here. So paano natin isa-subtract itong number na to? So you're going to put this. If you're going to use 856 over 34, ano mangyayari sa number natin dito? This will become now what? If we're going to do the operation.
856.
Okay, so this now become 4.607 equals to 9970 times 856 over 34. So that's around 25,000. Or no, 251,009, and that is your CFE, and this is equals to 856, right? And we can subtract this. So pag sinubtract natin yan, ibig sabihin, mawawala na to, di ba? So from 2 unknown, okay, we only have now 1 unknown. And all we need to do is just do the operation here. So 4.607 minus 0.109. So I have there a 4.607 0.183 times 856 divided by 34. So 4.607 minus 0.109. So I have a 4.498. And here, it's a 251,009 minus 84. So it's still around this one. CFE. And then I just divide both sides by this number. So you will get what? Did you get the same number as before? So aling mas
Yes.
madali? So I leave it up to you which way you're going to solve simultaneous problem. I mean, simultaneous determination of components in a given mixture. Now, if you have 3 components, then you're going to have just another plus in the absorbance total here. So I think this is the more challenging one. And then the way that you're going to do is use this value in one of the equation here. So you can use the 0.183, and that's what we did earlier, right? So you have 9970 there times 1.79 times 10 to the negative 5, and then plus 34 CCU. And all you're going to get there is the same number as you have earlier, which is what, 1.27 something, or 26 times 10 to the negative 4. So question. Question? May tanong? Okay, so let's proceed to the next one. So share this one. So ano naman tayo dito? Fluorescence naman. But as I've told you, it's all XY input and then get the Y equals to MX plus B. So here, to evaluate the method, a series of external standards are prepared and analyzed, providing the results shown in the following table. So all fluorescent intensities are corrected using a blank prepared from quinine 3 sample of urine. So quinine is a fluorescent sample, and you see it in tonic water. So it's one of the simplest experiments that you can do. Okay. So the fluorescence intensities are normalized by setting the intensity function there, or factor, for the highest concentration standard to 1 or to 100. Okay. So usually whatever the signal that you get there, okay, you set it to 100. So what makes this a little bit challenging is it's not only asking you for the concentration of the sample, but also the percent recovery. So it says here, after ingesting 10 milligrams of your quinine, a volunteer provides a urine sample 24 hours later. So analysis of the urine sample gives a relative emission intensity of 28.16. And then you are asked to report the concentration of quinine in the sample in milligrams per liter and the percent recovery for the ingested quinine. So what we're going to do here is similar to getting this, what we call Y equals to MX plus B. Okay, so you're just going to input. So right now we're just going to use Excel. So do you see the Excel right now being shared? So we just input here 1, 3, 5, 7, 10. And then you have here 10.11, 30.20, 49.84, 69.89, and then 100. And then the usual thing, getting the trend, or what we call the Y equals to MX plus B. So the challenge to you is doing it in a calculator. Okay. So if you're going to look at here, so you have Y equals to 9.9781, X plus 0.1218. Okay. So maybe I can bring this. And then hopefully I can attach it here. Hindi nag-attach. Oops. So if we're going to look at the number that we have there, okay, so what is that? 9.9781. Plus up top 0.1218. So what is the corresponding X when you have 28.16 as your Y? Or maybe I need to get here this one, yung whiteboard. So you have 28.16 minus 0.1218 divided by 9.9781. So ano yung nakukuha yung X? Anyone?
2.81 po.
2.81.
81.
So that is if we're going to look at the unit, microgram per ml. Now, is this the final answer? Final answer na ba to? Because if you're going to look at the question, what does it ask you? I'm going to show you the question again. So you ingest 10 milligrams of the quinine. So volunteer provides a urine. So you are asked, okay, what's the recovered quinine? So doon sa 10 milligram that you ingest, how much was recovered in your urine? So we're going to use that value, 2.81 microgram per ml. Okay, and then we could say that's a microgram per ml of a given urine, or of the urine that you have there. And how many ml is your urine? Nilagay ba dito yung, I think, I hope I shared that. After ingesting, so may kulang ata doon sa problem natin. Okay, so maybe we could just say ilang ml yung urine na gusto nyo. Because we need to put the value for the urine sample. I think I missed it in the given. So maybe let's say 2 ml of the urine sample that you have. So what we're going to do, we're going to convert that to milligram because you have microgram there. So you convert that one and over what? The mass of the sample that was ingested, which is 10 milligram. So the urine here is canceled, the microgram is canceled. So what you have there is the milligram. So ilang percent yung na-recover?
.06 po.
0.06. If you're going to look at, let's say, 3 decimal places or 3 significant figures,
0.0562 po.
percent. And that is, we could say, so small, but you could say microgram 2.81, okay, from the 10 milligram, so it's really a small number. So the last one that we have is similar still to this one. Ganun kasi yung ginagawa usually for spectroscopy, for quantitative analysis. So usually you set different concentration and then get the signal. So for instance, in this one, so this is an AES, atomic emission. So you have a series of standard addition prepared using 10.0077 grams of the sample of a salt substitute. And the results of the plain atomic emission analysis of the standard is shown here. So what is the concentration of your sodium in the salt substitute? Okay. So if you're going to look at this is a salt, what we call a standard addition. Okay. So alin dito yung sample mo? Which is your sample here? This one, because you didn't add any sodium to that, and it gives you this signal. Okay, so what you're going to do is the same thing. I think this is similar to a problem that we have during the beginning of the semester. Okay, so we can do an Excel again. So we input everything there. So you have 0.420, 1.051, 2.102, and 3.153. So you have your 1.79, 2.63, 3.54, 4.94, and 6.18. And then the usual stuff, you get that. So if we're going to have here, there's 1.369, or we could just say 1.37. Y equals to 1.37x plus, what's that number that we have there? 1.9739, or we could just say 1.97. Right? So what do we do? Paano natin sa solve to? Ano yung gagawin natin dito? Anyone? Remember, this is a standard addition, but it's a calibration curve. So we will set this to 0, right? And when that happens, paano mangyayari? So we will have here like a 1.97, which is a negative 1.37x. And then remember what happened if you're going to look at the calibration curve that we have. So we're trying to find, based on this curve, kung ang y natin, okay, is 0, ano yung corresponding x? We will get a negative, but usually, yung positive na yun yung sinasabi yung kung ano yung concentration ng sodium mo or salt when it was not added with any salt yet. So what's the corresponding value that you will get for the Na there? If you set that to 0, so 1.37, so that is equals to 1.44. Now, are we done? Ito yung mga tanong na paano, oh, tapos na ba tayo? But look what is being asked there. Okay? You get this from a sample, 10.0077. Okay? But what you have here, this is just the reading that you have from your solution. So if you want to what we could look at it, so there should be some other information that you can get here. Okay. So 1.44. So we could say 50 ml over 25. There's some missing information here because ang ano kasi itong representative method. Okay. So let's assume that we have a 250 ml sample there and then we dilute it. So kumuha tayo ng 25 and then dilute it to 50 ml. Okay. And then from that, we divide it from 10.0077 grams of sample. And what do you get? If you're going to look at the sample, so you have a 10.0077 gram dinisolved mo sa 250 ml. And what you do, okay, you get 25 ml of that, you dilute it to 50 ml. Kasama na yung standard addition ng sodium. So that's the missing info that you have that I'm providing now. So ano yung amount ngayon ng sodium mo in microgram per gram?
71.9 po.
So you have a 71.9 microgram per gram. So question. So ganun lang yun, usually quantitative analysis doon sa tatlo na diniscuss na natin, yung absorbance, atomic absorption, and luminescence or fluorescence. Now the last that we have, which is vibrational spectroscopy, you don't usually use it for quantitative analysis. It's more on qualitative. So there's no calculation on that part. Okay? So tanong, before we end our session. You can go over the sample problem that we have there in the handout. But as I've told you, this is the typical calculations that we do. I think the most challenging part here is this one, where you have two components in a given mixture. But the rest we could say a straightforward linear regression. So if you know Excel, it will be useful, but I would suggest try to do it using a calculator. Tanong class?
Elmer, may problem set ba tayo dito? Or quiz na lang?
Meron po. Pero I think it will be given by next week. So meron silang parang 2 problems na isosolve. So ang isa doon yung multi-component.
Okay.
That they
Yung
need
2
to,
equations in 2 unknowns.
Yep. So kailangan nila i-submit by what we call next meeting. Now the problem set is mostly, let's say, practical application. So let's say if you're given a sample, why are you going to use this method over the other method? So parang yung kagaya ng last problem set that we have some question, short written answer. And then maybe by later next week, you will have the quiz. And then we will start with mass spectrometry. So we're almost done. After mass spectrometry, it's electrochem. We only have around what we call 1 month left. Pero yung final exam niyo, I think we will follow the schedule, the university schedule, which is around January. So may break kayo, yung Christmas break, and then you take the final exam. So question?
Last question. Since straightforward naman hindi lang sila sumasagot, siguro baka gutom na. Pero very straightforward naman, and tingin ko makukuha kasi iba algebra lang
Yeah.